think we'll get started because we did this one yesterday and we overran. So I'm David Atkinson. I'm a product manager at Bedgate. So I'm covering the continuous integration project we're doing at the moment. This is David Simner. He's a software engineer and he's also a build master. So he knows a lot about how we run our continuous integration at Bedgate. So we're going to be covering top 10 tips for database continuous integration. So we're starting by defining what database continuous integration is. Then we'll be going through the top tips. We'll be demoing as we go along because we'd like you to see how you can get up and running fairly easily using, I'm hoping you all use Bedgate tools already, but if you don't, it should give you a good guide. And do ask questions. We're a fairly small group today, so I think it's going to be great if you just interact a bit with us and gives us an idea of how fast to go, how much detail to go into. So you'll have seen we've put white papers on the chairs, and they're there to pick up. This document will give you sample code, so you can take this code, you can probably copy and paste it from the online version of this document and use that in your own continuous integration setup, and it should get you up and running. So, what is continuous integration? I found a definition online. Jez Humble, he's a ThoughtWorks employee, and they have a continuous integration tool. In fact, they started off Cruise Control, which is a very popular tool, as an open source project, but now they have their own commercial one. But they're very knowledgeable about the subject, and he's written a book, a very good book, Continuous Delivery. I recommend it. And he defined continuous integration as a practice designed to ensure your software is always working and that you get comprehensive feedback in a few minutes as to whether any given change to your system has broken it. I think that's a great definition. It's all about getting feedback quickly. So you make a change and you find out whether that change has broken your build or not. And if it has, the first thing you do is to fix it because everyone else is relying on a good build. So what is database continuous integration? I think database continuous integration is a practice designed to ensure that your database is always working and that you get comprehensive feedback in a few minutes as to whether any change to your system has broken it. So I think you should be treating your database code like your application code. So stored procedures are code. So why should it be treated any differently? So if you make a change to your database, why not get the instant feedback that application developers have been getting all along? So this is the database delivery lifecycle, at least the continuous integration portion as we see it. So we have a team of developers, they make changes, they commit those changes to source control, that will trigger some sort of build process. And if the build fails, or even if it passes, you get instant notification back to development, so they can either rectify it or they have confidence to tell testers they can take a good build. And as we go along, we're going to produce some artifacts. Deployment script is an obvious artifact of a database continuous integration. You want to generate scripts that you can then run on your database that will upgrade your database, for example, to the next version. So this is the wider picture where you've included the deployment aspect as well. So at some point, you're going to decide that you need to deploy the next version of your product. And usually you have a DBA. Sometimes the DBA and developer are the same person. That deployment is not done continuously. So you don't want to deploy to your database all the time. If your customers generally don't want that. I mean, there's some products that do it fairly regularly. I think Facebook is a good example, and Spotify, Chrome. But you want to do it in a managed way. You don't want to do it every time a developer makes a change. So that DBA will take the script, apply it to production, and at that point you want to make sure that the production works. Because you haven't provided value to your user until the user is using the tool and getting value out of it. So you need to monitor this process continuously to make sure they are getting value, monitor for performance, monitor to make sure that there are no changes made by other people directly to production. your change should be going through this process, but in real life, somebody is going to make changes to production directly, and you need to know. So that's another reason why you need this loop here. And of course, what if a change does get made here, and it's a completely valid change, maybe it's an index that you've added to fix a performance issue that's critical, so you don't have time to go through this process, then the DBA needs to know that, and also the development team needs to know, because the development team needs to take that change, get it back into source control, so that next time it goes around, it doesn't drop the change. But today, we're not going to focus on that aspect, we're just going to focus on this continuous integration piece. So, tip 1, source control your database. Who here is source controlling their database? Who here is using SQL source control? Good. So, source control is the truth of where your application lives. So it's the truth for your application code and it's the truth for your database as well. And that's where continuous integration tools look to get the latest version in order to perform the build. And, of course, we have SQL Source Control, which is a tool that integrates into Management Studio. It's not a source control system in itself. It's not like TFS or SVN. It integrates with those source control systems and provides a link between the SQL Server development database and those existing backend systems that you probably have. I mean, I'm guessing who doesn't have source control at all in their organization? Good. So at this point, David will show you SQL source control for those of you who haven't seen it before.
Cool. So we'll be seeing more of SQL source control as we're going to go throughout the talk. But just for now, I want to kind of give you a very, very brief overview of it. So it's an add-in for SQL Server Management Studio, and it's completely integrated. So there's a tab here where you can see SQL source control, and we'll see more functionality as we go along. The icon in the Object Explorer for the widget dev David database has been changed to green, and it's that green icon that represents the database is under source control. And there's a tooltip that says that currently there are no changes to the database, but it's linked to source control. On the Setup tab, we can see where it's stored in source control. So we're using the evaluation repository here just because it helps if the laptop loses networking. But if I click on that, we can go through to, so in your organization, this would point to your SVN or TFS or Vault, and we support a whole bunch of other systems as well. So this is what actually gets stored in source control. So we have a whole bunch of directories for the different object types. So you can see there's a directory for stored procedures, tables, and so on and so forth. Inside the stored procedures folder, there's a whole bunch of files, and each object in the database has been scripted out to an individual file. And normally you won't have to manage these files directly because our tools do it for you. But just for people who are interested, we'll just take a quick look at one of these files. So if we open one of these files with Notepad, we can see that what's stored in this file is a create procedure statement. And our tools will generate the alter statements from these create statements when you're using them. And they'll also work out which is the correct order to run to change the object in the database into the dependencies are satisfied. But what's in source control, one file per this object, and we store the creation statements. So at this point, I'm going to hand back to David. Just close a few things, and then we'll go back to David.
Tip 2, get a continuous integration tool. So there are a number of tools out there. So you have JetBrains TeamCity, and that's the one we use at Redgate, so it's the one we use in demos as well. But it really doesn't matter which tool you have, because these tools just do the same thing. They monitor your source control system, and they do something when they see a change. So Microsoft Team Builder comes with TFS. Lastly, we have an offering called Bamboo, and cruise control is available still. It's open source, but it has been discontinued, or it's no longer as supported as it was, mainly because ThoughtWorks have a commercial tool and they're trying to push that instead. But all of these tools can be used for free, but with limited numbers of build agents and servers, so you can get up and running at minimal cost. So who here has a build server? Okay, that's most of you. Good. Out of interest, how many people have TeamCity?
Just trying this out.
Okay. So David will show you TeamCity and how you'd set up the demo.
So So although we're using Team City here, the principles that I'm going to show you apply to all the different systems that David has mentioned. So first up, we have, Team City has got a whole bunch of projects, and we're going to see the different projects as we're, and the different build configurations as we're going through the demo. So this one here updates the database to the latest revision in source control. And the way that works is that in Team City, we have configured it to go and look in Subversion for exactly the place where SQL source control is going to commit database changes. So this URL here is the place where SQL source control is going to commit changes to. In practice, when you're not using the evaluation repository like we are here, this would point at precisely the same URL as is present on the setup tab in SQL source control, so your Subversion server or your TFS server. And that's how Team City knows where to go and get the database from. So what we're going to do now is we're going to make a change to the database, and then we're going to see how that change is represented in Team City. So the change that I'm going to make is to one of the store procedures in the database, and it's to the PRC add contact store procedure. So because the definition that David gave at the start is how when we make a breaking change to the database, we can see that breaking change represented in continuous integration, so we get that immediate feedback as to whether we've broken the system or not. So lots of the things we're going to demo today are deliberately breaking the database, just so that we can show you that the continuous integration server does give you the feedback that the database has been broken.
It's also convenient. If the demo goes wrong, we can claim that it's intentional.
So we have here a store procedure, and it takes an email parameter, and at the moment it's defined as a varchar 30, so up to 30 characters. And the change that I'm going to make is, instead of having 30 characters, we're going to have 20 characters. So clearly this is a breaking change to the database, because if you call the store procedure with a 25-character string, previously you'd get the string in its entirety, whereas once we've applied the change, we'd get the first 20 characters of the string, the last 5 would be truncated. So if I so you can see here that I'm writing an alter procedure statement to update the database. And if I press F5 to execute this, a little blue indicator will appear over here in the Object Explorer. So there it is. And so this blue indicator is SQL source control telling you that there's been a change made to the database that you haven't yet shared with your team. So if I right-click on the store procedure and then go to the commit tab, we can send this change off to the source control system, and then obviously the continuous integration server can pick it up, but also your teammates can pick up the change as well. And SQL source control lets you see what you're committing before you commit it. So we can see here the change. The right-hand side is the latest thing in source control, which is 30 characters. Left side is my database, which is 20 characters. So let's enter a detailed checking comment. So altering the strong PRC add contact to only allow 20 character email addresses. And we click the commit button. And so that has now gone ahead and sent off that change to the Subversion server. So if we go into Team City, we can see that because there is a VCS trigger here, so Team City needs to know when it should run builds. And the VCS stands for version control system, and so this is watching the Subversion, and every single time there's a check-in, it will trigger a build. And it's happened so quickly that we can't see it, so it's already happened at 9:59, and it took 10 seconds. And the build was successful. And that's because at this point, we're not, all we're doing at this point is updating the database to the latest revision. We'll see in one of the future tips how we can test that database to see that the store procedure is not behaving correctly. So I'm going to hand back to David, who's going to talk a bit more detail about what this build has actually done.
So update your database. So that's what we've done. So what is updating your database, and why should you do it? So those of you who have build servers running already will probably be compiling application code in the build servers. Those applications often need databases to run, and if you're running unit tests, those tests may rely on the existence of a database, and that database needs to be of the corresponding version. So if you make an application code change that relies on a database change, and you've got CI set up, it's going to fail unless you have a mechanism to keep your database up to date as well. And that's why you might want to update a database in continuous integration. So this is how we do it. The SQL compare tool, obviously it has a very nice user interface, but it also has a command line. And this command line allows you to do everything that you would do in SQL compare, just by using various switches. These examples are in the white paper, and if you go to webgate.com/CI, and that's also in the white paper, you'll get a bunch of other resources that will help you. So here you can see it's just taking a folder of scripts which represent the database. These are the creation scripts, and this is the target database. So you can see this, it's targeting a database called Always Up to Date DB on my 2012. So, and David will quickly demonstrate.
So this is why, when I said at the beginning that the things we show you apply to all source control systems, all we're using TeamCity to do is to run a command line. And so whether you're using cruise control or team build or any of those, because they can just run command lines, that's why the principles we're showing you apply to all different continuous integration systems. So, so this is how we set up TeamCity. So we set it up just to run the command line. So the command line is identical to the one that David mentioned, because it's also got the /sync flag, which actually causes the command line to actually do it. But yeah, it's updating the up-to-date database by using the SQL compare command line that's installed in the program files. So one thing I'm just going to show you is that it's actually worked. So if you go to the always up-to-date database and just take a look at the store procedure, PRC, and contact, and take a look, you can see that the email is 20 characters. So this is because the build has finished successfully. This database is now up to date. And if we were running a test against their application, or if we were just running the application, it would be able to use the newly up-to-date database that incorporates the change that we made. So I'm going to hand back to David at this point.
So it's a good segue on to testing. So we built a database, and we've probably done some application testing with NUnit, for example. But since you've got code in your database as well, why not unit test that as well? So all database tests, unit tests, could be run in Management Studio, because we have a SQL test tool that we'll show you later, but they can be run as part of continuous integration as well, and they should do, because changes that you make and test on your machine may work on your machine, but integrated with other changes that other developers have made could result in breakages. So SQL test provides Management Studio integration, so IDE integration, to an open source framework called TSQLT. So it's not a framework we've written as a company. It's like NUnit, it's an open source framework, and there are various integrations of that tool into Visual Studio and other IDEs, and we've done the same for TSQLT, because we believe TSQLT is the best open source framework for SQL. And another bonus is that TSQLT has integration to CI tools, so it's already got a way of outputting a report that is compatible with existing CI tools. So we put in an option in SQL compare to ignore TSQLT objects. So the way TSQLT works is that it puts a bunch of store procedures and functions into your database. And of course, you don't want these changes in your production database as well. So you need some way of excluding them, and the way we do that is that SQL compare will just ignore them when it generates its deployment script. And it ignores the actual tests as well. So you can get a clean deployment script and ensure that changes, non-desired changes, don't go.
The default setting?
The default setting is to not ignore them. So we show everything by default, because otherwise you might be a bit surprised that there are some objects that you don't see in the comparison results. And of course, there may be valid reasons why you want to copy over the framework. So if you're moving to
we need to go and check that box.
Yes, and you can save it to your defaults if you want. We have another tool called SQL Data Generator. If you want to generate some data and to run some testing on that database as well, maybe some volume tests, performance type tests, and that's a tool that you can consider using as well. So at this point, I'll hand back to David, who will give you a brief overview.
Cool. So in TeamCity, when we checked in the change earlier to truncate the parameter from 30 characters to 20 characters, as well as updating to the latest revision, it also ran this build here. So you can see that this build here ran 4 minutes ago. And so you can see here that 4 of our tests continue to pass, but crucially, one new test started failing. So one test started failing. So we can drill down and see the details. So we can see that that's the name of the test. So it's testing the add contact store procedure. we can drill down even further and see what was going on. So the test was expecting the result sleepinthecity@red-gate.com, but what it got was sleepinthecity@red- and then it gets truncated at that point because these are the first 20 characters. Because it's failing for the first time in this build, we're interested in which changes were incorporated into this build so that we know who to blame. So if you go to the Changes tab, we can see that there was one change in this build, and it was me, and we can see the checking comment here, which is alter the store procedure to only allow 20 character email addresses. If your developers aren't providing detailed checking comments, you can click here, and then you can actually see what they did. So we can see that I edited this store procedure, and we can even see even more detail by clicking on this, and then TeamCity will show us the differences before and after. So we can see that on the left here it's 30 characters, but it became 20 characters. And so this lets us drill down to see the change that was introduced in this build that caused this test to start failing. And at this point we can assign it to the developer to fix, and we can also explain to the developer that by using SQL test inside SSMS, they can run the test before committing, which means that they don't actually introduce these breaking problems in the first place, which means that they don't kind of interrupt everybody else on the team by having this breaking build, so that other people's changes can't be tested because this test is blocking that from happening. So if we go back into SSMS, so SQL test is just like SQL source control, it's completely integrated into SSMS. So if we start up SQL test, so basically it has a little window down here, and it lists all the databases that you've got in the Object Explorer that have got tests in them. And so this is my database here, and you can see that we've got a whole bunch of tests. And last time I ran them at passing, but of course, because I didn't run them after making my change, then who knows what state they're in. So first up, we're going to just run these tests, and we can see that the add contact test is failing. And it's not surprising that it's failing because we've seen that same failure in TeamCity. We can also go and see the message here. So it was expecting sleepinthecity@red-gate.com, but it got the truncated string. So we can see the failure message in SSMS just as we can in TeamCity. So at this point, we're going to take a look in further detail at the test. So if I just double click on this, it opens up the test. So tests in TSQL are written as stored procedures in your database, which means they get to be source controlled alongside the actual database itself. And they tend to have 3 separate regions to the test. So the first kind of sets things up. The second executes the bit of code under test, and the third checks that the bit of code under test behaved appropriately. So the first thing, so this is the PRC add contact store procedure which we're testing, and you can see the email address parameters being passed in here. And then to test, we're just asking TSQL to check that the 2 strings are equal. So at this point, we can, so one of the features we've added to SQL prompt recently is F12, which lets you kind of step into store procedures. So if I put the caret on PRC add contact and press F12, SQL prompt will generate me an alter proc statement for it, so it makes it really easy to navigate around both from tests, things that are actually testing, but also more generally when you're just kind of exploring the database. So we can see here the alter procedure statement that we wrote earlier with the email address as 20 characters. And what I'm going to do is I'm going to put that back to 30 characters and just press F5 to execute that. Again, the little blue indicator appears here to show that I've got a change to commit. And this time around, we're going to run the test before committing. So if we run the test, you can see that it's now got a green tick because it's passing again. And so at this point, I'm going to commit my changes to source control, the store procedure to fix the test that was broken because we were truncating email addresses. And then I'm going ahead and press commit. So now we've sent that change off to the source control server. TeamCity will pick that up. It will redeploy out of the up-to-date database. It will rerun the tests, and this time around the test is going to pass. So I'm going to hand back to David, who will talk about next day.
Number 5, test your deployment scripts. So there are 2 types of deployment scripts. One, probably more than 2 types, but 2 main types. One of them is the database creation script, and that's a script that builds a database from scratch. And if you're an ISV, for example, and you have multiple customers out there, some of them will not have your product, and therefore they need to build a database. So you need the creation script possibly wrapped in an install. Or it could be useful internally as well to build some tests and dev environments. And then you have upgrade scripts. So unlike application code, database, upgrading a database is much more complex. You can't just delete the old one and replace it with a new one because you have data that's in your database that needs to persist. So you need to, there's an upgrade procedure that's not trivial. So why not test it? So it's an important part of your project delivery is upgrading the database. Why leave it till the last moment to test that your upgrade script will work, or even to write your upgrade script? Often we talk to customers who don't think about their deployment scripts, their upgrade scripts, until right at the end. And with tools like SQL Compare, especially SQL Compare command line, you should be able to generate these things all the time and test them automatically as part of continuous integration. So, how do we do that? So, the way it works in our continuous integration script is that we create a new test database in our CI environment. So, it's a completely blank database from scratch. We then use the SQL Compare command line to apply the production revision to that database. So we know when the revision of the production database we last deployed. And therefore we can apply that revision from source control to that database. So it becomes a database that is like production. Obviously it's not equivalent to production because it doesn't have your data in it, but it's of the same schema revision. Then we use SQL Compare again to generate the upgrade script that will take this production-like database to the latest in source control. And we use the SQL command to run the script. So we don't let the tool do it itself, because obviously you're going to be running a script when you deploy yourself. So we're trying to be as close as possible to your actual deployment process here. And finally, we use SQL Compare again to compare the database that we've upgraded in our continuous integration environment to what it should be, which is the latest revision in source control. And if SQL Compare confirms that they're the same, then the upgrade has been successful. So this is the upgrade test that we've run, and David will show you how that works in TeamCity.
So what I'm going to show you is, so this is the build configuration that's doing that, which is updating the database from the production revision to the latest. And at the end of the build, we have these artifacts. So by default, when a build is over, TeamCity will keep the results about whether the build passed or failed, and the test passed or failed, but it will throw away all of the files on disk that we use as part of the build and generated as part of the build. And artifacts is how you tell TeamCity which files you'd like to keep. And one of the files that we're asking it to keep is the upgrade script for the schema.sql. So this is the file that David was talking about, that SQL Compare generated, and we use SQL command.exe to apply to the database. And so because we've kept this, we can then give this file to our DBA, who will be able to upgrade production using this script, with the knowledge that this script has been validated in the CI environment to actually successfully upgrade the database that had the same schema as production does. So if we just take a look at this file in Notepad, so we can see that this is a script being generated by SQL Compare that will update the database from revision 4 to revision 28. And revision 4 is the revision that we happen to know is on production. And David's diagram at the start talked about how we had the database delivery lifecycle and how we had the schema monitoring on production, so we knew when it's changing. So we're really confident that actually it is revision 4 on production, and then revision 28 is the latest revision in source control. And so this is the script, and as you can see, it's automatically generated by SQL Compare to make all of the changes to the database. So at this point, I'm going to hand back to David.
So, what if the upgrade fails? So, has anyone here tried to rename a table at all, or a column, possibly, and try to deploy that change using SQL Compare or any schema comparison tool? Yeah. What happens?
Tries to drop the one you want to keep and throws all the data away if you're not careful.
Exactly. So SQL Compare sees the before and after state and tries to guess what happened in between. And if you've got a new object and one that's disappeared, it doesn't know whether you've renamed it or whether you've actually created a new one and deleted an old one. And the same applies to a column as well. So we're going to go ahead and do this just as an illustration.
Cool. So if I go into SSMS, we're going to make this change in, and then commit the change using SQL source control. So clearly it's only tables where this change is interesting, because obviously for any other objects there's no actual kind of data associated with them, so you can't just drop them and recreate them. But for tables, which is where you've got the data that you need to preserve, that's where it's important to get this right. So I'm going to rename the widget descriptions table from widget descriptions 3 to widget descriptions 4, and I'm just going to refresh the SQL source control commit tab. So SQL source control has detected that the widget descriptions 3 table has disappeared, so it thinks you dropped it, and it noticed the widget descriptions 4 table has appeared, and so it thinks it's been created, and it doesn't realise that the objects have been renamed. Because of these changes result in data loss, SQL source control is warning you, so it puts this little red exclamation mark on every single row. So this is the list of changes, and of course there can be lots of these, and then we display a scroll bar on the right hand side. So each of the rows that result in data loss get this little thing, and because the row may not be on the screen at the moment, we also put this big orange thing at the top here, right underneath the commit comment, saying that these changes may result in data loss, and you can add a migration script to preserve the data. And the migration script is basically the next tip of how we're going to deal with this fact. But just for now, I'm going to ignore the warning, just because not everybody reads warnings, and so it's important that the continuous integration tool actually stops the build from happening and will fail the build if there's data loss. And so we're going to see that happening by actually going ahead and committing the changes here. So I'm going to just send a checking comment, which is rename the widget descriptions table and press commit. So this change has now been sent off to the version server. Continuous integration will kick off, and as we're going to see in a minute, it will have detected that the data loss has occurred and will fail the build. And we can hand back to David and talk about some other scenarios where this occurs as well.
Yeah. Obviously, the danger is that if that script passes continuous integration, the DBA takes that script, applies it to production thinking it's being tested, and of course, the intent was never to drop the table at all. So, where schema comparison tools struggle? So we know that they don't have very much information available to them because they don't have any developer intent. They have the before and after state, and they have to guess what's happening in between it. And that works for most things. You know, if you change store procedures or add columns, change data types, it's fine because it doesn't need to know any more information. But here's a typical example where if you've ever tried to add a not-null column without a default value, if you try to apply that script to a database that has data in that table, it's going to fail. It's not SQL compare's fault because it doesn't know how to populate that new field because you've added new values. You've specifically not added a default, and it can't be null. So renaming table column, we covered that. That's obviously something that is ambiguous. It could mean two things. So he doesn't have that information. Splitting a table column is the exact reverse. It's not reverse. Splitting a table column is where you take, let's say, a full name and you split it into first name and last name. SQL compare doesn't know how to do that because you obviously have to put some logic in to say how to split the name up, where the delimiter is. And, it just doesn't have that information. So there's some logic that you've written to do it that SQL compare doesn't have. And merging is the opposite of that. And of course, any data migration you do that has code that you've written to do that data migration, SQL compare doesn't have access to that information. But that's where custom migration scripts come in. It's the ability to give SQL compare the knowledge that only you have, and for SQL compare to then use that in subsequent deployment script generation. So it overrides the built-in behavior. And if you think about it, this is essential for any automation. It's okay having SQL compare misinterpret a few things or not have enough information if you're just generating a script using the UI, because you can go in there, make the change yourself, save that off, and that's fine. But in an automated environment, you can't do that. You can't have a manual step every time someone makes a check-in. So this is an essential feature in order to test your upgrade scripts as part of CI. And as we alluded to earlier, continuous integration can catch data loss. So there's an option in SQL compare that tells it to fail when a data loss warning happens. And this is something that I would recommend you turn on for continuous integration, because that will catch all issues like the rename or any accidental column or table drop. This is a new pane in the deployment wizard of SQL Compare. Because SQL Compare will pick up migration scripts, it will look in source control, and will use that information to build the scripts. And this little diagram shows you how that's happening. So the grey bit here is where it's generating the scripts in the usual manner. But it knows that between 36 and 37, it's got to take this script from here. So it knows to pull that information in, and in this case it appends it to the end of the auto-generated script. And we'll go back to see what our table rename has done to the continuous integration.
So if we go back to TeamCity, we can see that the build has failed. And the build has failed because there was an issue found when generating the schema upgrade script. So we can see more details by going to the build log, and if you just scroll down to the bottom, we can see that there is a warning. So the warning, the table widget descriptions 2 is being dropped, and data will be lost. You can use a migration script and SQL source control to solve the problem, aborting due to the high severity warning. So as you can see, the build has failed, and so because the build has failed, we know that we shouldn't. We know that we've made a mistake, and we should go and fix the mistake, so that now the table won't be dropped and will be recreated, because we can tell SQL Compare the custom logic that we want to have applied instead. So you create migration scripts in SQL source control. So previously we saw how on the commit tab it was offering to allow us to create a migration script because it detected that it was a good idea to create one because of the data loss. But if you don't create one there and then at the time, you can always go back later. So on the migrations tab, you can add a new migration script. So this is the history of the database that we're showing here. So these are all of the changes that we've made, and we need to select the one that the migration script covers, which is the one at the top, which we've just committed. And we can see the check and comments and what happened in that commit. So if we click Create and Edit Script, SQL Source Control will generate the default script that SQL Compare will run. So this is what SQL Compare wants to do by default. So by default, it wants to drop the primary key constraint, drop the table, create a new table, and then add the primary key constraint back in. So if you're only wanting to make a small change to what SQL Compare is doing, because the default script is here, it's really easy just to go in and make a small change to it. In our case, though, we want to change absolutely everything. So instead, we're going to execute SP rename, which takes 2 parameters. So the first parameter it takes is the name that it starts off being, which I'll just copy paste, and then widget descriptions report is the name it ends up being, and we'll just delete all of the SQL Compare default. So now we have the migration script to go from revision 28 to 29, which is executing the SP rename. So the next thing to do is to commit that migration script to source control. So migration scripts are stored in source control, just like your database, so you get all the same benefits of knowing who's creating them, why they're creating them, when they're being edited or deleted, and the check and comments, so that you can see all the changes to the migration scripts, just as you would see all the changes to your database in the audit history. Also, because they're stored in source control, and because we've configured TeamCity to kick off new builds where the source control changes, that means that committing this will trigger a new build in TeamCity, which will then start using this migration script, and then the build will pass, because now the rename will be done with this script, as opposed to the default SQL Compare behavior of dropping and recreating, which causes data loss warning. So add a migration script to cover the rename. And obviously, just as anything else in SQL Source Control, you always get to see what you're committing before you commit it. So that's the migration script, which is really short in this case, but if you are splitting or merging tables, it's a lot longer. So we click the commit button. That now sends the migration script off to source control. TeamCity will stop the build, and once it does its thing, I'm going to hand back to David to talk about the next step.
Tip 6, get familiar with scripting. So we've shown you a few basic examples of how the command line works. You'll need to invoke those command lines somehow, and these are the various popular ways of doing it. So you can use PowerShell, NAND, MS-Build, and they're pretty similar to each other. NAND and MS-Build are nearly equivalent. They're XML sort of build script engines. PowerShell, how many people here use PowerShell? Okay. It's just, you have to invoke the command lines via PowerShell at the moment. We don't have commanders yet. Something we're considering. These are the regular tools that have command lines. So SQL compare is the one that's doing most of the work in the demo that generates deployments with the schema. If you want to do the same for data, you can do that because we can source control your reference data as well. That's an option. And doc data generator, packager, and SQL test. You can script SQL tests via the T-SQL-T functions that exist. So please go to the website if you want more information on those or contact support. So tip 7. So we've explained how we upgrade databases, or we test the upgraded databases. We create a blank one, we make that production revision, we generate the script, we apply the script, and we validate it with SQL compare. However, that's not the same as testing against production. And because you don't have the production data in that, so it could be that the upgrade works in continuous integration and fails if you apply it to your production database. So what's the point of doing it in continuous integration if you're not going to get those results? So you want to test against production really, and that's what you do in a staging environment, but you don't want to do that all the time because there are various issues associated with it. So is it possible to do this real production data restore as part of your continuous integration environment? Is that practical at all? And yes and no. So there's time to restore. So if you're checking in all the time, you might check in, an average developer may check in between 5 and 10 times a day. And if you've got a whole bunch of developers making those changes as well, then you're going to kick off continuous integration quite a lot. So you can't really afford to have a very long continuous integration process because that's just going to build up and you'll need more build agents and will just take a long time to run and they'll queue up. So that's really not very practical to do that on every check-in, but what we can do is we can change the build trigger to run every so often, so maybe nightly. If it takes a day to store your backup, production backup, maybe do it on Sunday, and so just do it weekly, so that's an option. Data sensitivity. Not everyone is allowed to take their production data and put it into their development environment for testing purposes. So what can you do there? So we've got a tool in preview, so it's a beta. We haven't decided where to take it yet, and it's called SQL Data Masker. And that can be downloaded from gate.com/labs. We'd like you to try it out, and if you have any feedback, there'll be a feedback mechanism within the tool. We'll just email anyone at Redgate, and they'll be pleased to forward your feedback onto the right person. So that allows you to specify various columns to the mask, and it will just change those columns. And hopefully you'll have a database that is okay for development and testing purposes. So storage requirements. If you have a huge database in production, you don't necessarily have the same huge storage environment in development. In an ideal world you would, because you really want your test environments to be as close as possible to production. But in practice, that might not be an option because storage can be expensive. We have a tool called SQL Virtual Restore that does some magic. So it allows you to mount a backup file. So instead of restoring a backup and taking up pretty much the equivalent space of the database, you can instead mount a backup file, and that appears to SQL Server as if it's just a normal database. So if you think about it, backup files have all the information they need already to be a database. So why duplicate it? So this technology lets you use a backup file as if it were a real database. So you can use this technology in your continuous integration environment to simulate production. And you can read and write to it as well, because it maintains a data and a log file as well. So all the deltas, they go into those but everything else it fetches from the backup file. Tip number 8, document the database as you go. So we have a tool called SQL Doc that generates HTML or Word documentation based on your database and shows you the schema and the scripts, the application scripts. So you can run the SQL Doc command line to generate those, and it's something that you can do, for example, when you have a successful build, to keep documentation available for developers, so they can go in and they can see what changes have been made recently. So David will quickly show you what that looks like in Teams.
Cool. So just before we look at it, we're just going to, oh god, no. So we have a slight issue with the demo. So I was supposed to show you that the bill is now passed, having checked my migration script. What's actually happening is it's still failing, and I don't know why. So we'll skip over that and look at the SQL doc. So one of the nice features about SQL doc is that because it generates the documentation in HTML, and because TeamCity is a website, TeamCity just gets to show you the HTML documentation that SQL doc has generated in a nice tab here. So we configure TeamCity, so the artifact remember is how we tell TeamCity what to save, the files that were generated as part of the build. So we've asked TeamCity to save the SQL doc documentation away, which is generated in HTML, and so there's a SQL doc tab, which basically just renders that HTML in the browser in TeamCity, and this is one of the quite nice features in TeamCity. So if we go to our favorite store procedure, which is PRC add contact, we can see that here is the email column, which we've been changing, and it's 30 characters at the moment because we fixed the test failure earlier to move back to 30. So yeah, this generates all the documentation for the different objects in the database, and you can see it in the web browser. So I'm going to hand back to David, who can talk about the next step.
How easy was it to set up that?
Set up the
So the command line takes, so if you look at the command line, it takes the project file. So the project is .SQL, the db.SQL doc. So if you run the SQL doc UI, and then you basically pick all the options that you want, and then you click save project in the UI, that will generate that SQL doc file. Then all you need to do is check that file into source control, and then when you set up the build in TeamCity, you can just tell it to pull that project file from source control. So any changes you make to that project file, so if you're going to change the options for how you generate documentation, they get source control just as your database would. And then output folder just tells you where to write the documentation. And then all you need to do after that is tell TeamCity what to save as an artifact. So we can see that, which is just the artifact path. So this is just saying, please just save away this folder. Please save away this folder. And the next thing we need to do is to just tell TeamCity to, that's not what we've done it in the admin pages. So in the admin pages, you can tell it report tabs, and you can see that if ever any of our builds have SQL doc/index.html, we should put the SQL documentation tab on the TeamCity UI. So it's just a very small number of settings in TeamCity, and the project file, which is the hard bit, you can generate as through the SQL doc UI, which is why we always recommend for the command lines. Which is why we recommend that if you have the command line license, you also buy a license for the UI of the tools, because they can generate an awful lot of the project files that the command lines can then read in. It's much easier to configure the projects in the UI, because obviously you get a nice UI to configure the settings for things.
Yeah, cool. Tip number 9. So this works in Visual Studio as well. So you've demonstrated SQL source control, we've made a change, that kicks off continuous integration. What if you want to commit changes atomically between your application database? You've got some application changes that rely on a database change, and you haven't committed them yet, and you know that if you commit one, it's going to fail your build because the other change hasn't gone in yet, and so you need to commit them together. So that's one reason why you might want to do it from Visual Studio, because you've got your Visual Studio project as part of your solution, and you can have a database project as part of your solution. And SQL Connect is a new tool that we've released recently that lets you manage your changes in a Visual Studio solution. So David will demonstrate how that works.
Cool. So this is Visual Studio here. So SQL Connect is an add-in for Visual Studio. So you can see that we've got the SQL Connect window down here. And so SQL Connect is basically kind of like a sister tool to SQL Source Control. So while SQL Source Control works at its best, SQL Connect works in Visual Studio. As we're going to see in the demo, you're going to have part of your team using one of the tools and part of your team using the other tool, and they can communicate together by checking into the same place in Source Control. So what SQL Connect does is it's a project that sits in your solution. So Visual Studio has the concept of solutions, And in your solutions, you have lots of different types of projects. So maybe projects for SSIS or SSAS packages, but also projects for C# applications or libraries or ASP.NET MVC websites, etc., etc. And we're just a project type, just like every other project type. So we can sit in the solution alongside other projects. And it's the fact that we're all the different parts of your entire system are all in the solution together that lets you do the atomic commits that David talked about, where you can commit both the application change and also the database change at the same time. So what SQL Connect does is it keeps a database in SQL Server synchronized with a bunch of files on your hard disk. And so because it does that, you get all the advantages of having your database as a bunch of files. And so the source control add-ins for Visual Studio support source controlling files because your C# application is a bunch of files. So because SQL Connect has turned your database into a bunch of files, you can now use your existing source control add-in for Visual Studio, whether that's Visual Source Safe or Subversion or TFS or Vault or any of them, it doesn't matter. SQL Connect supports them all because SQL Connect just gives them files and then they just go and source control files just as they would files in a C# project. So yeah, any changes you make to one of them, SQL Connect can synchronize to the other. And it does that when you press this big button down here. So what we're going to do now is we're just going to update the solution to the latest version, which is going to go and get the changes that I've been making in SSMX throughout the talk. SQL Connect displays this little blue indicator down here, which indicates that there have been changes made to the project files that I haven't yet put into my SQL Server database. And the changes to the project files are the changes that we've just got by doing that subversion update. So if I click the synchronize button, SQL Connect does a two-way synchronization. I'll click through that, that's because that's the same part I did earlier. So SQL Connect does a two-way synchronization. So it synchronizes both the database to the project and the project to the database simultaneously. And it does that because it knows what changes have been made to each. Cool, so we've now taken the changes we're making in SSMS and we've pushed those changes to the database. So at this point we're completely in sync and we can start making a change. So what I'm going to do is I'm going to change a stored procedure. And let's say I change the get contact stored procedure. So by double-clicking on the stored procedure in the, so normally when you double-click on things in the Solution Explorer, like C# files, what you would get is a view of the C# file where you can go and make some changes to the actual file. For SQL Connect, we've done things slightly differently. So when you double-click on this stored procedure, what we've opened up here is a query window where you can change the database on the real database running on SQL Server. And the reason why we've done this is that not only do you get lots of feedback from SQL Server about constraints in your database, if you try to do something that you can't do, you get immediate feedback from SQL Server saying, no, that SQL was invalid or that constraint was violated. But it also means that you can instantly test your application. So because you've been changing the database, you can run your application or your website, and you can instantly see whether it works with your database change. Then, when it comes time to share those changes with the rest of the team and with your source control system, you click the synchronize button, SQL Connect turns those changes that you've made to the database back into the files, and then you can source control those files. So let's say, so because this is a query window, I get full SQL prompt integration if you've got it installed. So this is SQL prompt here. So let's say we want the person's phone number at work. So I click execute query, and that's changed to SQL Server. SQL Connect displays the database changes to synchronize, and it puts a little orange blob here, akin to the little blue blob we saw earlier on the other side, that indicates that we've made a change to the database this time. I click the synchronize button, the two-way synchronization happens again, and this time the project file has been updated. The project, there's now this little red indicator here. So this little red indicator is being shown by the source control add-in that we're using for Visual Studio, which in this case is AnkSDN, but the TFS and Vault and VSS add-ins, again, they put icons here too. So this icon means that the project file has been changed, and so we can now share that with our team by doing right-click commit. So this is AnkSDN, which is an open source plugin to Visual Studio that connects your solution to Subversion. So modify Xproc to get that phone numbers. And I click OK. So AnkSDN has now committed the project file to the source control system. And this will have kicked off a build in TeamCity because it's a change to the source control system. So if we take a look here, you can see that there's one, too quickly. So you can see that Team City is currently building, and if we hover over this drop down, we can see that that's the change that I've just made. So modify the source procedure to get the phone numbers too. So that's kicked off the continuous integration process, just as the other changes that we've been doing. If we go into SSMS, as I alluded to at the start, you can have some of your team working in Visual Studio with SQL Connect, some of your team working in SSMS with SQL Source Control, and they can collaborate together as long as the databases they're using are connected to the same place in SDN. Because as you commit from one tool, because the two tools write and read in the same file formats, you can commit from one tool and see the change in the other tool. So here we are on the Get Latest tab of SQL Source Control, and we can see the change to Get Contacts. And we can go and take a look at the difference at the bottom, and we can see that this comma has been added, and the phone work is here, but on this side we have that. So we can see the changes that our colleague in Visual Studio has been making, and then to get the change into our database, it's as simple as pressing the Get Latest button, which brings the changes down from the Subversion server and applies them to our database. And now we can build on our colleague's change and make further changes to the database. So it's that easy for the people in SSMS and people in Visual Studio to share changes between them. And hand back to David for that final tip.
You've discussed this very much in the context of centralised source control systems. How do you find that this is sitting with people using DCSs?
We're looking at adding Mercurial support, so native Mercurial support to SQL Source Control over the coming months. And which DBCS were you?
Well, I've been using Mercurial by Atkinson and Cal recently, but I've also been looking at Git because it seems to be actually slightly better.
They are similar tools. We are looking at Git as well. So naturally, after Mercurial, we would implement Git, and we're implementing in a way that would make it easy for us to do that.
So the point is that apart from the migration to functionality, SQL Source Control and so SQL Connect supports everything because it's whichever Visual Studio add-in you've got. So if you install whatever it is, Visual, HG, or SQL Connect will just work. SQL Source Control does support Git and Mercurial at the moment, but it supports it by calling the command line, which obviously means that you don't have things like the nice history dialog, which we haven't seen, but SQL Source Control has a very pretty history dialog, which is living at the moment, which shows you all of the kind of changes you've made to the database. That relies on us kind of having native support, so we can get the history. And so basically, if you're using Git or Mercurial, you just don't get the history window, but everything else, and also migrations you don't get as well, but everything else in SQL Source Control, so committing and getting works fine. The important thing is that throughout the talk I've been using the phrase commit. The equivalent term in distributed systems is push, and similarly the get latest, the equivalent term is pull. So it's just a matter of kind of switching the lingo out for the equivalent step in the distributed version control system where you share changes with your colleagues.
Does every developer need their own database now? Because you've got rigid dev.
So SQL Source Control supports two ways of working. So if I just move this over to the left, so we support the dedicated model, which is where every database developer has their own database, and they're using source control to share the changes. And our tool makes that really easy through the Get Latest tab and the Commit tab. Sometimes that's not very practical, normally because the database is huge or because that's just not how you're used to working. And we also support the shared approach, which is here, because where all the developers are working on a single database, and then source control is still here as the point of truth, so that you can still have continuous integration running off source control. You can still have your deployments to production can still be from source control, so you know you're deploying a particular division that you know is good. SQL Source Control works slightly differently in the shared approach. So the first difference is the Get Latest tab just is disabled because there's no concept of getting because everybody's working on the same database. And the second change is that the Commit tab shows you who made the change. We read information from the SQL Server default trace, which tells us for each change on the Commit tab who made the change. So when you visit the Commit tab, by default, we only tick the changes that were made by you, and we don't tick the other people's changes. And then if you do select someone else's change, we put up a warning that actually you may be committing someone else's change. The reason why this is useful is because when you're committing to source control, you're going to be committing to source control from your user account. And so whenever you look back at the audit history later of what's gone into source control, it's quite nice to be able to see that it was that developer who made that change, so you don't who to blame later or who to go to for questions about how exactly is that working. So because of that, the commit tab, by using the default trace, can just tick the ones that you've made so you don't commit other people's changes.
Is there a reason why you have to use shared, or is it for practical reasons?
It's size and number of clients we're working on.
Okay. Okay. So it's possible to use the SQL Virtual Restore tool to mount a backup file and to use that as a development environment. And the clever thing you can do there is you can mount it multiple times. So you can have one backup file and n number of mount points on it, and these are different databases that different developers can use. So that's an option open to. So, tip 10. So everything that we described today is possible to do now, so you can download and try it out. But we're evolving this as we go along, so we'd like to improve the experience, we'd like to put in DPCS support, we want to improve migrations functionality so it doesn't fail in demos. And so we'd like your feedback. So we'd like you to try this out and to let us know what to do next. So we've got usability tests that you can participate in, where we do screen sharing, you walk through some new features, or surveys we send out, for example. So if you're interested, please come and leave me the details afterwards, or speak to anyone at any of the pods in the main foyer area, and just ask them to be put on any early access lists that we have for continuous integration or any of the tools you saw today. So we're going to show you a quick preview. I know we've gone over time, but for Team City, we're looking at making the experience much simpler, and we've got a plugin, and David will show you what that looks like briefly.
Cool. So as I mentioned earlier, because working out which command line switches you need to use is often quite complicated, and so lots of our tools have the ability to save the project in the UI and then have the command line just use that project, which also makes it easier to set up. But clearly some people don't want to use the UI version of the tools or pay for them and so forth. So one of the things we're doing is we're writing a plugin to TeamCity so that instead of having to set the command line up as I did earlier, you get a nice pretty HTML UI. And basically the things that you type in these checkboxes are based on how you choose on the radio buttons. We will generate the command line for SQL compare based on what you've entered here. And so this makes it very easy to configure SQL compare. And so this is how it looks now, but it's still in development. At the moment, we'll probably have a single tick box. So in the future, we'll have a single tick box to run my SQL tests, maybe a single tick box for both the scripts that I've mentioned before, so both create me a database creation script as well, do me an upgrade, text box for your production provision, and so on and so forth. So we can extend this over time based on feedback as to how people are using the command lines and what they'd like to make it much easier to configure. So you can just pick options here as opposed to reading the documentation of command lines and having to wait for the different switches.
And we can do plugins for Bamboo as well, and for Team Build and any other continuous integration tool if there's sufficient demand as well. Okay, I think it's probably done. So I'd like to draw your attention to this track here. It's very relevant today. So later on today, David Green and Annette Allen are talking about continuous integration and their experiences, because they're not Redgate employees. They actually put it in place, and that's a good talk. So I went there yesterday. If you're interested in SQL test and test-driven development, TSQL-T, the founders are here, so we invited them to speak. So they're speaking in 4 o'clock. Developer track, and if you're interested in the Visual Studio plugin, SQL Connect, then Noemi and Tom are covering that in their session as well. Right, any questions? I know, apologies for going over time, but is this something that you guys think?
Just a quick one, the shared database one that you use, I mean, we use that word. Is it something you're looking to phase out?
Not at all, not at all. In fact, we're putting in a new feature very soon that will allow you to persist the information that tells you who made the change to the database better.
That's what we know, because it uses the logs, doesn't it, to see who
yeah.
It's inaccurate, we find.
It uses the default trace, and the default trace rolls over, you know, so when it gets to the end, then it sort of gets thrown away. So that information doesn't persist very well. So we're putting in a feature that lets you create a database to persist this information.
Yeah.
So we're actually doing the opposite. We see that the majority of users out there are using the shared database model, and so we want to support it better than supporting it now.
So I think the proper way to do it is everyone have their own you know, that's the
Yes.
correct security.
In an ideal world,
Yeah,
yes.
exactly, but I mean, but in a my environment, we can't do that. So.
Exactly, and there are lots of reasons, also valid reasons why you can't do that, and we accept that, and we will improve the story then. Further questions? Right. Thank you very much.